Welcome learners, in the part 2 of this video. We are looking at the inverse of a matrix by using row reductions. Okay, and this is the definition of a inverse of a matrix. And the method is we take a augmented matrix EI, we perform the elementary, rather I should not say elementary, we should apply the row operations on this matrix and we make this A as identity matrix. Corresponding operations will convert this I into some matrix, and that matrix is nothing but our inverse of a matrix. And in this process, suppose we are getting a row which is entirely 0, then the inverse does not exist. Okay, and this is the example what we have done in the previous video, part 1. So as I said, let's take a matrix which will give us a a row which is entirely 0. And of course, you can also show that if inverse exists, then it is unique. Okay, so let's take an example. Let us show that the inverse does not exist in this case. So find the inverse of, let us take a matrix A is equals to 1 to 1 minus 2 1 8 1 minus 2 minus 7. Let us take this matrix. Okay, and if does not exist, so we will change the question or show that it does not exist. Okay, so let's move solution from the augmented matrix. The augmented matrix, what is my augmented matrix? A I. Okay, and this will be matrix A. What is matrix A? 1 2 1 minus 2 1 8 and 1 minus 2 minus 7. Okay, and this side you will have 1 0 0 0 1 0 and 0 0 1. This is our augmented matrix. We'll apply row operations on this matrix, and let us try to convert this matrix into identity matrix. Okay, so let us apply the operations. Let us write here. Let us put first operation. We have already 1 here, so there is no problem for 1. Let us make this 0 and this 0. Okay, so let us take 1 by 1. R2 changes to R2 plus, already minus 2 is there, so plus 2 times R1. So minus 2 plus 2 will give you 0. So let us operate that over here. So first row as it is 1 2 1 1 0 0. Third row will be also as it is 1 minus 2 minus 7 0 0 1, and our second row will change. And how it will change? It will take second row, it will multiply 2 to the first row and add it to the second row. So minus 2 plus 2 you will get 0, 1 plus 4 you will get 5, 8 plus 2 you will get 10, correct? Then 0 0 plus 2, so 2 1 0. Okay, so we got this 0. Now let us operate on this matrix. Let us make this 0. And how we will make this 0? We will take the third row and we will change it to third row minus first row. We will use the first row for the first column. Okay, first entry over here. And with this we will get a matrix. Now in this case we are not doing anything for the first and the second row, so both the rows will be same. So 1 2 1 1 0 0. Second row will also be same, so 0 5 10 2, 1, 0, and our third row will change. How third row will change? By using the operation R3 minus R1. So this minus this. So it will be 1 minus 1 0, minus 2 minus 2 minus 4, minus 7 minus 1 minus 8. Then 0 minus 1 is minus 1, 0 minus 0 is 0, 1 minus 0 is 1. So this is the matrix what we will get, right? Now using now we got 1 0 0. Now what we made one is this one. Okay, and if we divide throughout by 5, we will get 1 here, and 10 by 5, which is again 2. So we can divide by 5. So let us operate that operation here to make this 1. Okay, and also we can make this row 1. Let us take one by one. So R2 will change to 1 upon 5 times R2. Okay, so again we are changing only the second row. So the third row and the first row will be as it is. So let us put that first row as it is: 1 2 1 1 0 0. Also 0 minus 4 minus 8 minus 1 0 1. And our second row changes. We are dividing the second row by 5. So 0, this will be 1, this is 2, this is 2 upon 5, this is 1 upon 5, and this is 0. Okay, now let us make this one. Okay, we can make this one. It depends on you how you proceed with the operations, not a unique way. I will make this one first, this 0 first, or you can make this 0 first, you can make this one first. It's up to you how you proceed. Okay, so let us make this as say let us divide this by 4 minus 4. So when you divide this by minus 4, we will have 0 1 2, and also when you divide this by minus 4, we will have minus 4 divided by minus 4 1, minus 8 by minus 4 2, and we will have two identical rows, and we can make entire 0 rows. Okay, also we know that if there are two identical rows, the determinant will be 0. So let us divide this by minus 4. So R3 will change to 1 upon minus 1 upon 4 times R3. Okay. Again, as I said, it depends on the operations which you are following. I am using this operation, you can use some other operation. Okay, there is no hard and fast rule that you have to use these operations only. So R3 changes. So first row as it is: 1 2 1 1 0 0, then 0 1 2 2 upon 5 1 upon 5 0, and this you are dividing throughout by minus 4. So 0, this is 1, this is 2, this is 1 upon 4, this is 0, this is minus 1 upon 4. Okay, and we can operate one more operation, and we can make this entire row 0 0 0 0. And simple operation is we can change R3 to R3 minus R2. And under this operation, we can make the entire entries in that row as 0. Okay, so first row as it is: 1 2 1 1 0 0, then 0 1 2 2 upon 5 1 upon 5 0. This is 0, 1 minus 1 is 0, 2 minus 2 is 0. Okay, and here we will have another entry which is here 2 upon 5 minus 1 upon 4 minus 2 upon 5. We can calculate that. We will get minus 3 by 20, and 1 upon 0 minus 1 upon 5, it is minus 1 upon 5, and this is minus 1 upon 4. And now notice that this is a row which is entirely 0. Okay, so this means let us partition here now. Go one by one. This you can do simultaneously, but I'm okay with even if I don't put. So for your understanding, let us put this. Okay, It's okay even if you don't put that. So if you notice here, the zero row on left hand side or left means we cannot get cannot get identity matrix here. Identity matrix here, right? And thus A is not invertible, and a matrix which is not invertible is called a singular matrix. Okay, if A is equals to 0. So in this case we have a matrix for which this is equals to 0. In that case we cannot convert this into identity matrix. If you cannot, you can try, you can operate any row operations, but you cannot convert this into identity matrix. Now based on these operations, I got this third row as 0. You can perform your operations, you can make any of the row as 0. Okay, so hence the inverse does not exist for this matrix, and that's what we have also exhibited. So as a concluding remark, let me put you give you two examples that you solve. Exercise: find inverse or show that it does not exist for, let me give two matrices, say 1. First matrix, let me give 1 1 minus 1, 2 minus 1 1, and 1 1 2. Okay, you operate the row operations to make this or find the inverse of this. And second matrix, let me give again 2 by 2 3 by 3 matrix. I will give 2 3 1, 2 3 1, minus 1 2 1, and 4 minus 1 minus 1. Okay, so try to operate use the row operations and try to get the inverse of these matrices, or show that by using the previous this example, show that it does not exist. Okay, in the next video we will see the Gaussian elimination method to solve the system of equation.